audible? Hello everyone. Am I audible? Please confirm in the chat window. Is my screen visible? Am I audible? Then I'll be starting with the questions. Okay. So let me start the questions. Let's start with some easy questions. Okay. Okay. So for us, the first question is, what is the difference between data profiling and data mining? Okay. Okay, please put your answer in the chat window. For this, I'm giving you 1 minute. So it is asking, what is the difference between data profiling and data mining? Power says no idea. Okay, I think you all know what is data mining. Data mining is subset of ML and AI. Okay, Sita. Okay, let me give the answer for this. So data profiling basically focuses on analyzing individual attributes of the data. Okay, so thereby providing valuable information on the data attributes such as data type, frequency, the length of the data along with the discrete values and ranges. So these things we can get while doing data profiling. On the other hand, data mining aims to identify unusual records. That means to analyze the clusters, to find the sequence, and so on. So this is the basic difference in data profiling and data mining. In data profiling, we find the attributes, and here we analyze the sequence and clusters. Means to find the records of the data. So this is the difference here. Yeah. So I'm also getting the answer. No issues, Paris. This one subject. Okay. Yeah. Yeah, you got it correct. Okay, so let me ask you the next question. So for you, the next question is, what is confusion matrix? I think all of you have idea about it. So tell me, what is confusion matrix? Yeah, Paresh, I can write those things, but whether like whenever it is required, I will definitely write it. But if I will start writing these things, it will take like many times and we will not be able to touch more questions. Like whenever it is required, I'll be writing. And whenever I am doing this session, please be ready with your notes. So you can do the running note. It will be easy for you. And it will also save us some time. Okay, Paresh. TPFP. Okay. This these things are the parameters that we calculate. Okay. Confusion matrix provides details about. Okay. Okay. Can anyone tell me whether it can be 2 cross 2 matrix or it can be more than 2 cross 2? Okay. Chris Combs is saying n cross n matrix is used for evaluation performance of classification where n is the target. Okay. Okay. So obviously the thing is the confusion matrix is a table that is used to estimate the performance of a model, and it tabulates the actual values and the predicted values in a matrix format. Yeah, power. It can be more than 2 plus 2. But we name it differently. Can you tell me what is the name? When it is more than 2 cross 2, what will be the specific name of it? Yes, we can call it confusion matrix, but it has a name. Okay, when you are giving me the answer, let me put the next question like of the session. It is also an easy one. Yeah, we call it cross table matrix. When it is 2 cross 2, we can directly call it like say it is simple confusion matrix. And when it is more than 2, we can say cross table matrix. And we can also say cross table. So what is dimensionality reduction? And what are the algorithms that we use to perform this? And what are the benefits? So please tell me these three things. What is this algorithm that we use and what are the benefits? Reducing the size of the data to increase the computation and reduce the computation burden. Okay. Whenever you are talking about reducing the data means you are talking about the dimension, right? Okay. Yeah, PCA, PCA, LDA. Okay. Also we use SBD, right? Yeah. So obviously the dimensionality reduction is the process of converting a data set with a high number of dimensions to a data set with a lower number of dimensions. We basically reduce the dimension here. So how can we do it? This is done by dropping some fields or some columns from the data set. However, this is not the process that we always follow for everything, because as we know, for SVD we can go for some imagery data set. So in this process, the dimensions or fields are dropped only after making sure that the remaining information will still be enough to describe the information. Otherwise, what will happen if the suppose we have an image, okay, and it is not defined well pixel by pixel. So what will happen if we drop some part of it? We will lose some information and we will not be able to perform our algorithm, and we will not be finishing our model because we have lost some information. So we have to mark that thing. Yeah, okay. I hope it is clear. Let me put to the next question. So whenever we are talking about the features, let me ask you one more question regarding it. So what are the feature selection methods used to select the right variables? Okay, Vishwanath. So what are the feature selection methods used to select the right variables? So there are different types of methods, but mostly we divided into two parts. First, tell me what are the two parts that I'm saying. Then in those parts, we can say further things. Here I'm talking about feature selection, not reduction. If Sita is saying subset selection method, okay, and Power is saying correlation spearman, Sachin is saying forward and backward. So whenever you are saying forward and backward, you mean selection, right? Okay. Biswanath is saying by keeping the most relevant variable from origin. Biswanath, this is the that we do means without using any model that we do in Excel file. Here I'm talking about when using ML algorithms, how can we select a feature? Random forest. In random forest, how can we select the feature, please? Yeah, lasso is also, yeah. Yeah, this is a nice answer. Okay, let me explain this to you. So, like how you can give the answer, there are two main methods of feature selection. Okay, let me write this for you. Whenever I'm talking about two methods, so we have two methods. Number one is our filter method. Okay, filter method. Here we have what? Can anyone tell me? Okay, let me give the answer for it. Then I'll be explaining to you. So here in filter method, we have ANOVA. These things no one gave the answer, right? ANOVA, chi-square test we do. In filter method, we also have linear discriminative, linear discrimination, discrimination analysis. These are the things that we do in filter method. Yeah, the other one is wrapper method. Yes, someone gave the answer for this. Yeah, Ipsita, yeah. Other one is wrapper method. So this is how you should give the answer. So in wrapper method, we have the types of selection that we do. Means the forward, backward, and the other one is what? Recursive feature elimination. Recursive feature elimination. So these are the methods that we use. Okay, yeah. So what happens in the filter method is, so basically the best analogy of selecting features is bad data in, bad answer out. That means we are limiting the selection of the features by cleaning off the information of variables. Means whenever we are having the importance of a variable, that means it has more information in it, right? So we can calculate the information and the importance of a variable, then we can select it. But in wrapper method, it is like labor intensive. So what will happen is, here we do data analysis. By doing some data analysis, we perform feature selection. So this is the basic difference. Okay, I hope you got it right. And also, as someone said, lasso reads also we can do. Yeah, it is one exception, but we can do it. Lasso reads we can do for feature selection. Who gave the answer for this? I think Power gave it, right? Yeah. Okay. Let me put the next question. So for you, the next question is, it is a very simple question. The last time we have discussed how to find out an overfitting model. Now let's discuss how can we avoid overfitting your model. How can you avoid overfitting your model? So please try to answer this in your chat window. For this, I'm giving you 1 minute. Okay, power is saying by doing careful cross validation. Yeah, we can do that. Abhishek is saying by reducing the complexity of model. Obviously, that means keeping the model simple, right? Yeah, correct. Chris is saying training more data. Training more data, do we use it for overfitting? Here, to avoid overfitting, we need to consider less variables. Okay, Chris. Vishwanath, you are saying to increase number of features means you are adding data. When do we add data? To avoid overfitting or underfitting? Hmm? When do we add data? We do it for underfitting, right? To avoid underfitting. Okay. So overfitting refers to a model that is only set of a very small amount of data and ignores the bigger picture. That means, yeah, using regularization technique, yeah, we can do that. The first thing we should do is, as Abhishek said, keeping the model simple. We need to reduce the complexity of the model. So for this, we can take fewer variables, means less variables into account, thereby removing some of the noise in the training data. Just like we add noise to avoid underfitting, here we have to remove the noise for underfitting, sorry, for overfitting. And the next thing we should do is use cross validation technique, such as k-folded so. And the third and the last option that we have to avoid like overfitting is to use regularization techniques. Just like we use lassories, right? So we can do that. So this is how you we can avoid overfitting in a model. Okay. Let me ask the next question of the session. So what is the significance of the p-value? Whenever I'm talking about the significance, remember you have to restrict your answer to the p-value. Means whether it is equal to 0.05. We know, right? The threshold value is 0.05. So we have to put our significance with respect to that value. What will happen if it is less than equal to 0.05? What will happen if it is greater than 0.05? And what will happen if it is equal to 0.05? So put your answer according to that. What is the significance of p-value? Yeah, that thing we got it right. What is the p-value? It okay. It is not 0.5. It is 0.05, Ipsita. Yeah, power. P low is null को P high null high. Okay. Just give me a second, guys. Okay. Yeah. So I think we got a correct answer here. So when it is less than 0.05, null hypothesis is rejected. Okay. Okay, Abhishek. Also, Sachin is giving the answer. Okay, let me put the answer for this. So whenever the p-value is less than 0.05, yeah, we should say it is statistically significant. So this indicates the strong evidence against the null hypothesis. That means we can reject the null hypothesis here. And whenever it is more than 0.05, this indicates the weak evidence against the null hypothesis. That means you have to accept the null hypothesis. And whenever the cutoff value is 0.05, so it could go either way. So this is the thing. Yeah, also I'm getting answer from Vishwanath and Shalini. Statistical significant. Yeah, yeah, Vishwanath. Yeah, Shalini. Okay, so I hope you all got the answer here. So let me put to the next question. So for you, the next question is, what is information gain in decision tree algorithm? So tell me, what is information gain in a decision tree algorithm? For this, I'm giving you 1.5 minutes. You should answer this one. So I'm getting answer from Sachin. Information gain difference between entropy before and after. Okay, Sachin. Anyone else? Vishwanath is saying information gain is the main key used in data to construct a decision tree. Using this, okay, decision tree you are saying, okay. Power is saying information gain is defined as the information that can be extracted from an event like sun rises in east, no information can. But when we say disaster, okay, yeah, you got it correct, Power. Okay, I think you all are getting it correct. Lakshmi says reduction in entropy. Yeah, it is inversely proportional to entropy. Okay. So whenever we are building a this tree, at each step, we have to create a node that decides which feature we should use to split the data. That is, which feature would best separate our data so that we can make our predictions. Okay, so this decision is made using information gain. So this is basically a measure of how much entropy is reduced when a particular feature is used to split the data. So the feature that gives the highest information gain is the one that is chosen to split the data. So this is the process how we should calculate the information gain and how should we use to find the best value or the feature that we can use to split the data. Okay. Yeah, so I'm getting answers here also. Ig equals to entropy parent minus, okay. Okay, we are putting the formula here. All right. I think you are getting the answer. So let me ask you one more question. Okay, let me ask you one question from Python. Let me ask you one question from Python. Not one, couple of questions from Python. Then we'll be moving to the normal questions that we face from data science part. Okay. So tell me, how will you measure the Euclidean distance between the two arrays in NumPy? So how will you measure the Euclidean distance between the two arrays in NumPy? So whenever we are, let me give you a hint. Okay, Power says no idea. But I think you must have used in some model building whenever you are finding some distance. Okay, no issues. Let me give you a hint. First of all, as we are finding the distance, we need two arrays. So we have to define two separate arrays. Then we have to make, like we have to put a function to find the Euclidean distance. So it is a 3 lines of code. First, we have to import NumPy as NP. Then we have to use function. Okay, I think no one else. Okay, everyone is saying IDK. Let me give the answer for this. Okay, so as we know theoretically, whenever we are going to calculate the Euclidean distance, we have to like measure the distance between the two arrays, right? Okay, so it is talking about Python, right? So we have here, we have imported first, we have imported the NumPy. We know that. In second, we have to define the first array. This is, suppose this is the first array. In third, this is the second array. Okay, so we have defined the two arrays. Now we have to put the function to find the distance between it. For this, we can use, suppose we are finding the distance, then we can use np dot linalog. This is line, sorry, alg, not alog. It is alg dot norm, and inside that we can write a minus b. So this is it. Now if you write dist, it will give you the answer. So this should be the function. This is the function that we should use to find the Euclidean distance. Okay, I hope you got it. Vishwanath is saying np dot square root np dot sum. Yeah, see, the thing that you are doing, this thing we can do directly in this function. We don't have to do it manually. Also, if you want to define a function, you can also do that. But here we are having a function, so we don't have to do like this kind of things. Okay, I hope it is clear. So this is the function that we should use. Yeah, I think it is clear. So let me go to the next question. Okay. So for you, the next question is, what is the difference between error and residual error? This is also an important question. What is the difference between an error and a residual error? Please try to put your answer in the chat window. For this, I'm giving you 1.5 minutes. So it is asking about the error and the residual error. Okay, I'm starting to get answers. Error equals to actual minus predicted, residual actuals minus predicted. Okay. Error is a difference of actual and predicted value. Abhishek says error is used for the trained data with residual error term used for the test data. Power deleted something. Okay. Okay, let me give the answer for this. I hope you all are getting correct. Okay. So an error occurs in values while the prediction gives us the difference between the observed value and the true value of a data set. That means the true value that we have and the value that we observed. And the residual error is the difference between the observed value and the predicted value. Then the reason that we use the residual error to evaluate the performance of an algorithm is that the true values are not always known to us. So in this case, we need to use the residual error. Hence, we use the observed values to measure the error using the residuals. So it helps us to get an accurate estimate of the error. Yeah, yeah, you all are getting it correct. But to be very specific, I just explained it theoretically. Okay, okay. The next question is a very quick question. It should not take more than 10 seconds. So for you, the next question is, let me increase the font. When do we confidently declare that a time series has become stationary? It is a one-liner answer. So everyone should try to put your answer. So it is asking, when do we confidently declare that a time series has become stationary? When there are no trend, no seasonality. When there is no trend and seasonality, no noise, no trend and no seasonality, in absence of seasonality and trend. Yeah, you all are getting it correct. Also, there is a another way we can do it. Whatever you are giving, the answer it is correct. Also, we observe the variance and mean of the series. Suppose we are having a series data, time series data. We observe the variance and mean of the series. If both of them are constant over time, we can say it is stationary. Okay? Yeah. Yeah, you got it. Yeah, you got it correct for this question. Yeah, it is an easy question, right? I said. Okay. Okay. Let me put the next question. So this is a question that has been asked multiple times, like many times. When do we use the classification technique over regression technique? So it is asking, when do you use the classification technique over the regression technique? So it is a very easy question, also an important one. When we have discrete data as the output, okay, then we can use classification, right? Okay. When we want to calculate a qualitative over quantitative values. Okay. Also, please tell me some examples of classification techniques and the example of regression techniques. Means which model we use in classification techniques mostly and which do we use in regression technique. Yeah, you got it correct. Please tell me the examples. Classification, decision tree, KNN, SPM. We also can use SPM in regression, right? Okay, that is correct. Power. Salini is saying when our output variable is categorical discrete, we prefer classification. Okay. Okay, let me give the answer for this. I think you all are getting it correct. So, classification problems are mainly used when the output is the categorical variable or discrete variable, and regression technique we use when the output is continuous. Okay, so in regression algorithm, we attempt to estimate the mapping function from input variables to numerical or continuous output variable. Okay, so for example of regression is linear regression that we use, support vector machine we can use, and some regression trees. And in classification algorithm, we attempt to estimate the mapping function from the input variable to the discrete or categorical output variable. For example, logistic regression that we use, also Navy bias, decision tree, KNN, and so on and so forth. Okay, yeah. So I think you all are getting it correct. And from this, we can also say one thing, SBM can be used as a classifier and as a regressor. This is also a important thing we should remember. Okay, let me ask the next question. So it is also a Python one. So it is asking what function of NumPy will you use to find maximum value from each row in a 2D NumPy array. Shalini, logistic regression we use for classification problem. Okay. Because the output is discrete, right? Not continuous. In logistic regression, the outputs would be binary class and discrete. Remember that, Shalini. Okay. Now tell me what function of NumPy will you use to find maximum value from each row in a 2D NumPy array. Okay, Power. Power, I think you have very good knowledge in data science algorithm questions. And you need to work more on Python questions. Not Power, everyone should work on it. Okay, to remember the functions. Because whenever you are going to appear for any interview, there will be one round of coding. So in that, they will be asking mostly the lambda function and the array part. They will be asking how to map a function using the lambda function. Okay. Yeah. So please try to nurture this part because it is asking only one function. Okay, let me give the answer for this. So in order to find the maximum value from each row in 2D NumPy array, we use a max function, that is a NumPy function. So let me write it. If we are going to, so the function will be np dot amax. Inside that, you can write the input and the access. Okay, so this is the function that we use, the amax function. Please remember this one. Okay, I hope you got it now. Okay, so let me go to the next question. I think we have enough time to discuss two more questions. Also, as we know, we end the session with some neural network questions, right? So let me ask you two questions. If possible, we can do three. So tell me, let me increase the font. Explain how a probability distribution could be not normal and given example scenario. So there is a condition, from that we can say the probability distribution could not be normal. Okay, please quickly put your answer. I think we still can discuss two more questions. For this, I'm giving you one more minute. Not 1 minute, 30 seconds. Multiple perceptron. Ipsita, perceptron. This is not a question. So this is not a question from AI Spry. Sorry, not AI Spry, I'm saying, not AI part. Yeah, so let me give the answer for this. So a probability distribution is not normal if most of its observations do not cluster around the mean. Because whenever we are going to find the mean of a distribution, if we see that most of the observation do not cluster around the mean, cluster means it is not grouping around the mean, then we can say it is not normal. So it will form a bell curve. We know bell curve, right? So it will form a bell curve. So it is asking for an example. So uniform distribution will be a good example of non-normal probability distribution. Remember that whenever someone is asking Give an example of non-normal probability distribution. Tell him that uniform distribution is an example of that. So here all values are equally likely to occur within a given range. They will be not clustering around the mean. Yeah, so it is the thing. So let me ask you the last question. I think yeah, we cannot discuss two questions here. So this will be the last question of the session. What are autoencoders? This is a neural network part question. Tomorrow, I am planning to ask you 3 to 4 questions from neural network because interviewers are asking more from this part. Always we discuss one question, right? Okay. Okay, guys, tell me what are autoencoders? You have 1 minute for this one. If you don't know, you can say I don't know. Okay, you want tomorrow full questions from AI. The thing is, Power, some people are not having AI course, right? So if I will be going deep into AI, they may face some trouble. But tomorrow, I can say one thing that I will be asking 5 to 6 questions from AI. Also, obviously from Python. Yeah. So tomorrow we'll have almost 10 questions from Python and AI. Okay. Yeah. So let me give the answer for this one. So an autoencoder is a kind of artificial neural network. So it is used to learn efficient data coding in an unsupervised manner. So it is utilized to learning a representation or encoding for a set of data. Mostly whenever we do dimensionality reduction, then by training the network to ignore signal noise, we use this thing, means the autoencoder, because it tries to generate a representation as close as possible to its original input by reducing the encoding. So it is reducing the encoding. So for that, we can say it is also reducing the dimension. So this is how we use autoencoder. Okay, so it was the last question of the session, guys. I hope it was an useful session for you. Okay, so have a nice day. We'll see you again tomorrow. So tomorrow we'll be discussing more on AI and Python. Okay, bye bye.